Yes, you're on air. You can start.
Okay, cool. All right. Hello, everyone. My name is Nishi Ajmera. I am back again with another session on AI agents. In today's session, we're going to talk about AI agents. What are agents? How do you build one using Google's agent development kit, and how do you deploy it on Google Cloud on Agent Engine? Okay, so let's get into it. A brief introduction for myself. My name is Nishi Ajmera. I work as a solutions architect at Publicis Sapient. I am a women tech maker ambassador, passionate about promoting diversity in the world of tech. I'm also a Google developer expert in AI and ML, and I do a lot of sessions, a lot of talks on AI agents, LLMs, focusing on everything about Gen AI. All right. This is our agenda for today. So I'll start with a brief about what are agents, how agents evolved, and then we'll get into Vertex AI Agent Builder, Agent Development Kit. We'll talk about how to deploy your agents using Agent Engine, and then a brief about Agent Garden as well. All right. So what is an AI agent? AI agent is a software system that autonomously perceives its environment, makes decision, and takes action to achieve specific goal. Okay, that's the definition. We'll understand it through different examples, key components, and everything in the coming slide. So, but first, let's talk about the evolution of agents, right? How did agents evolve? So, the first thing was LLMs back in like 2 years back, I think, when ChatGPT came. We had LLMs, and the only interaction between your LLM was you send a prompt to the LLM. The LLM will respond with the answer to your query, and the response is was mainly from the knowledge with which it has been trained on during its training process, right? That was initially when LLMs came about, and it did not have knowledge of the external world, right? Then, because LLMs had like their knowledge had an expiry date, so we wanted a way to provide LLMs with the relevant knowledge, with the latest updates to whatever it has been trained on. We brought in a concept called RAG. RAG is retrieval augmented generation, where you fetch relevant context from database or from a PDF or from any external entity. You fetch the context, you provide that as an additional context to the LLM to answer the query, right? So that it doesn't hallucinate, it give more fact based responses to you. Then we added in tools, right? So we wanted our LLMs to talk to our services. Like if I want my LLM to answer queries related to my orders, or just like if I want to check what's the status of my order, I can just plug my AI system, plug my LLMs to external tools, which can be your APIs or which can be your databases. It can be anything. It can be a simple Python function, right? Then came in your reasoning loops. So your reasoning loops, LLM, RAG tools, the combination of this builds an agent that makes an agent. So now if you go and give a task to your LLM, the LLM can do reasoning. Okay, I need these are the tools which I have available. This is the additional context. If I need, I can fetch this from my RAG system. It has everything available. It will reason through, like it will figure out okay, to perform this particular goal, I can break it down into these three steps, and these three steps can use these tools, right? It can do the planning and then take action using those tools, and then perform a particular goal by itself. So that this whole system makes an agent. And then came in the multi-agent systems, where you have now multiple agents built in, and they are talking to each other. A classic example for your multi-agent system is your coding agents. right? You have one agent which is, doing the requirement analysis, one is doing the development, one is doing the testing, and they are working in collaboration with each other. Now, what makes up an AI agent? So there are key components which work together to which work together for an agent, right? So at the heart of an agent, we have our Gen AI models like Gemini, or like there are other models out there which provides the reasoning power, right? Then the next comes your tools. So agents uses tools to perform actions. Your tools can be your APIs, function, databases. It allows agents to interact with the external world to get information and perform actions. Then you have an orchestration layer which manages the agents and memory. Memory can be both your short term memory and a long term memory. Then comes your agent definition, right? So this is where you define your agent's profile, what is the goal for that particular agent, and what instructions it needs to follow to achieve that particular goal. And then you need an agent runtime which executes and manages the entire system when the system is invoked. Moving on to the Vertex AI Agent Builder. So Vertex AI Agent Builder is a suite of products to build and deploy your agents on Google Cloud, right? So we'll start with the models which Vertex AI provides. You have a lot of variety of models available for you. You have Gemini models. You have various video streaming models. Then you have a model garden where you can explore like models available either via Google and also via other model providers like Claude, OpenAI, etc. Uh, then we have Agent Development Kit. This is what you would use. Like this is a framework which Google is providing you to build your model, build your agents. You can use other frameworks which are available out there as well, and then you can build your agents using the other frameworks and deploy it on the Google Cloud ecosystem as well. But Google provides you Agent Development Kit, which you can use to build agents and multi-agent systems. Then you have Agent Engine. This is what you're going to use to deploy your agents in production, deploy and manage your agents in production. And then you have Agent Garden, which is basically a bunch of agents which are already available. You can just go there, explore it, and if you want to use it in your ecosystem, you can use it. You can explore Agent Garden to figure out what agents are available to use in your system. Then it also provides you with enterprise data and tools. So you can connect your agents to the external databases. You can connect your agents to the APIs using APG, like whatever is there, whatever is available in your Google Cloud ecosystem, you can plug in almost everything with your agents, right? So this is your Vertex AI agent builder for developers. Then it also has something for the business users where it has agent space, agent designer, and customer agent engagement suites. So in this session, we are going to focus mainly on the developer side of things. So we'll focus on the agent builder. Okay. Moving on to the agent development kit. Agent development kit is open source framework by Google to develop, test, and iterate on your multi-agent application. Now, agent development kit is multi-agent by design. You can compose many agents and tools in hierarchy. Then it has a rich model ecosystem, so you have a variety of models available. You can use that and build your agents. Then it comes with pre-built tools like search, code execution tools. It has the capability to integrate with MCP tools. Then you can also integrate with tools which are tools and integrations which are available outside of the uh, ADK ecosystem or the Google ecosystem. Like you can integrate with tools provided by LangChain, Llama Index, Crew.AI, and other frameworks which are available out there. Then it comes with built-in streaming. It comes with built-in streaming for audio and with bidirectional audio and video streaming capabilities, right? Uh, then it provides flexible orchestration with workflow agents. You can orchestrate actions across multiple agents and tools, and it seamlessly blends deterministic code with uh, generative AI reasoning for hybrid approaches for creating creative solutions that you can control. um, ADK includes an intuitive local UI for rapid development, testing, and tracing agent actions visually. We'll see this in the demo. The UI is very interactive, and it is very helpful when you are developing your agents, because you can actually trace the agent like what thinking process agent took, and then like you can debug it at various steps. So we'll look at the demo of it, and it will become more clear. Then built-in evaluation, yeah, it comes with built-in evaluations. So you can assess agents performance by evaluating the final response quality and execution trajectory. And then it comes with easy deployment. You can deploy it easily to Vertex AI, Cloud Run, GKE, anywhere anywhere you can run containers. Then building agents at many level of abstractions. So you can build agents in various ways. One is you can build your own agent, so you can use function calling and build your own agent framework. Then next level would be you use your low level orchestration frameworks, which are available like LangChain, LangGraph, GenKit. There are a lot of low level orchestration frameworks available. You can use that and build your agents, or you can use agent specific frameworks like Google ADK, AutoGen, Crew.AI. You can use all of these to build agents. Irrespective of the way you are building your agents, you can deploy your agents onto Google Cloud. You can deploy it using Vertex AI agent engine. Right. Now, getting into a few specific features of Agent Development Kit. So, one is that there's minimal boilerplate code needed to build your agents. So, if you see over here, uh, when you're building an agent, you just need to provide the name of the agent, the model which you want the agent to use, the description of your agent, instructions, and then you can provide tools. Like you see, the tools is a list of array, or you can provide sub agents, right? So if you're providing sub agents, uh, that will make your application a multi agent application. Right. Yeah, so we have seen the instructions. This is how you can provide the instructions. It is simple, straightforward. Then function tools. So yeah, your tools can be Python functions, your tools can be APIs. You just have to like provide the function names over here, and inside this function can be a simple execution logic, or it can also be a REST API call within these functions. That depends on how you're implementing. Then you can also use agents as tool. So ADK provides two capabilities. One is you can provide agents as tool, and another is you can provide sub agents. So there is a difference between providing agents as tool and providing agents in the sub agent environment. When you're providing agent as a tool, your agent is executed in the it is executed in isolation, but it is executed in the agent's context, right? While if you are providing multiple agents, like if you're providing agents in the sub agent, you're basically building a collaborative multi agent system where, let's say if I'll take a simple example of a coding agent where you have a developer agent and you have a reviewer agent and then you have a tester agent, right? So the developer agent is building your code based on the requirement. Once that developer agent's task is completed, it will pass the control to the reviewer agent, and the reviewer agent takes that control. Now it is performing its own actions. It is reviewing the code which is generated. Now, if it needs amendments, it will pass the control back to the developer agent. If not, it will pass the entire control to your testing agent. So these agents are working in isolation, and they have full control of what they are executing. While when you are passing an agent as a tool to an agent, you are basically working under that agent's environment. I hope that makes sense. Then there is this is another important feature which ADK provides, which is callbacks. So callbacks are very important because there are certain steps which you would want to execute before, before your request goes to your LLM, or once you receive a response from the LLM. You want some deterministic steps to be executed. A very good example for this is guardrails. So before your request goes into the LLMs, you want to ensure that there aren't any PII information in your user's prompt, or you wanna or once the LLM generates an output, you want to make sure that there's no bias in the output, and whatever output is generated, it aligns with what user has asked for. Like those all those validation checks, you can use callbacks for those kind of things. Then moving on to event streaming. So event streaming allows developers to get individual events so that they can update users during complex agent executions. Like let's say the agent started processing your query. Now it has decided that it has to make these two parallel tool calls. So then it emits events that, okay, these are the tool calls which I'm going to do, these are the parameters which I'm going to use to make those tool calls. So that is one event which is sent back to your client. Then once your tool execution finishes, you have the response, you send another event saying that, okay, this is the response which I got. And then it processes everything, it generates a final result. Your server will send another event saying that, okay, this is the final response. So ADK has inbuilt event streaming capabilities, which is quite useful. Then you can define input and output schema. You can define Pydantic classes. Uh, Again, it is you can integrate it with various tools. So we have seen that ADK provides you tools like search, code execution, and things like that, but you can also integrate it with the tools which are available outside. Like LangChain has 100 plus tools, GrewAI has 30 plus tools. You can integrate your agent with these tools as well. Then ADK integrates with Google Cloud Trace and Open Telemetry. So you can use this to trace the request response times. Like you can actually trace the steps of the agents, which step is taking. Like which step is taking how much time to process, how many tokens did a request take to process, like end to end. You can do all sorts of telemetry over here. Then moving on to Vertex AI Agent Engine. Vertex AI Agent Engine is a managed runtime for developers to deploy, manage, and scale agents in production. So you see here, using Vertex AI Agent, you can uh, you can deploy an agent to a fully provisioned runtime. You can define an agent in a framework, deploy it to a fully provisioned runtime. You can manage context, session memory. You can observe agents' behavior. You can call your agents using from your app or UI. And you can also register your custom agent in agent space. So uh, With agent, you can use the agent engine SDK to deploy your agents to production with a fewer lines of codes. And this provisions a fully managed runtime, which gives you CRUD APIs to invoke and manage your agents programmatically. It's built for enterprise governance. It offers security features like VPC, SE, um, and authentication. Through OpenTelemetry, Agent Engine is integrated with Google Cloud's observability suite. So clouds logging, monitoring, tracing, everything is available. And you can observe and understand your agent's behavior over time. You can invoke agent from any client, like your own application or website. And you can also register your agents in agent space for employees within your organization to discover and use your agents to get your work done. Right. There are also pre-built templates available in the Agent Engine SDK. You can use those templates and use them to deploy your agents, which are built using any of these templates. Moving on to Vertex AI Agent Garden. So, Vertex AI Agent Garden is curated agent samples and tools for developers to discover and accelerate agent development. Right. So, Agent Garden is where you will begin your agent building journey by discovering and learning about agent building capabilities. Agent Garden offers agent samples tailored to specific use cases. You'll access the source code powering the samples for common scenarios like data science, customer service agents. You can also find modular tools like connectors for BigQuery or Salesforce, or custom APIs from APG, Vertex AI tools like RAG and grounding, and custom tools like function calling. You can come to Agent Garden, like you can explore Agent Garden right now in Google Cloud Console and access the source code of Data Science Agent, or like whatever you can see on the screenshot. You can go and explore these agents, which are currently available in the Agent Garden. Okay, I think that's it from the slides. Let's move on to the demo. So for demo, I have a code lab which I'm gonna quickly walk you through. Uh, you can perform this code lab in your own time. It is very detailed. So if you scan this QR code, this will give you the link to the code lab. Uh, I'm now gonna move to the code lab. So this is the code lab. Yeah. This is the code lab. This is a multi-agent app. We are going to build a multi-agent app using ADK, Agent Engine, and Alloy DB. So our agent is going to talk, will have basically two tools. One is it is going to access a database to fetch status of some orders, and then it is going to create a PDF uh, for a requirement. So first, before getting into that, at least let me go through what we are building as part of this. So we'll build a multi-agent system to handle kitchens renovation. Let me, yeah, to handle kitchen renovations. So we'll build a system with three agents. One is your renovation proposal agent. Then another one would be your permits and compliance check agent. And then we will have your order status check agent. So this order status check agent, this we are going to connect it to the Alloy DB. And this renovation proposal agent is going to have a tool which is going to generate a PDF and save it in your Google Cloud storage. Right. Your renovation proposal agent will generate kitchen renovation proposal document. Permits and compliance agent will take care of permits and compliance related tasks. And then order status check agent will check order status of materials by working on the order management database that we have set up in the Alloy DB. Okay. Then, before you begin, you have to do some setup in your Google Cloud Console. So, if you go to your Google Cloud Console, you basically have to set your project with which you're going to work. And then you have to enable these permissions. So, you have to enable artifact registry, you have to enable cloud build, You have to enable AI platform, and you also have to enable run, because we are going to deploy a cloud run function. Okay. Then this step you can skip, but this is basically exploring what model would work best for your use case. So you can go to Google AI Studio, you can play around with the models which are available, you can see what works best. And then once you choose the model, you can go to the next step. We are going to use Gemini 2.5 Pro moving forward. Then once you have the setup in your Google Cloud Console, you are going to create a folder for wherever you want to build this agent. So if I go to my console here, I hope this is visible. Yeah, so you see I have already created my agents folder. I go inside the agents. This is my agent environment, and this is where I'm going to install my Google ADK, and I'm going to initialize my Python virtual environment. This is the project structure. I will open the GitHub repo and I'll walk you through the project structure. So you have the link to the GitHub repo in the code lab. Okay. So in your project structure, you will create a folder for agentic apps. Inside your agentic apps, you will have your renovation agent, which will have your agents, agent.py, your .env, requirements.txt, and your init.py. Your requirements.txt will have all the dependencies which this agent needs, and your actual logic is written inside your agent.py. So this is your agent logic. If I quickly go through this agent, it has a get ordering data function. It has the check status function, send email. Like, you can go through the code yourself. I'm just quickly going to walk you through how the agent is being built. So let's quickly, yeah. So you see over here, yeah, we have a root agent, and then we have our proposal agent, permits agent, and ordering agent. Now this root agent is your orchestrator agent, and to this agent we have provided these three sub agents. So you have a proposal agent, permits agent, ordering agent provided as sub agent over here. And if you look at the instruction for this root agent, we have given very simple instructions over here. You can actually, okay, let's actually go through the agent system instruction first. So this is your agent system instruction. And we are telling the orchestrator agent that you're a proposal, permits, and ordering agent for executing and managing kitchen renovation proposal for a homeowner. And then these are the tasks which it can perform. So it can create a proposal document if user doesn't have one already. It will create permits and compliance documentation. It's going to create a material list for ordering along with the quality control checklist, and it can place orders or track the status of the materials delivery, right? So this is the goals which it can perform. This is the instruction on how it should operate, right? So this is your system instruction. And then we need to also define when to use which agent, so that we have done it over here. So if the user asks to create a proposal document, then we are telling the agent that you need to invoke proposal agent. If the user wants to create a checklist of permits and compliance documentation, we are asking the user to create the permits agent. And for ordering, checking the status, we are asking it to invoke the ordering agent, right? So this is our root agents definition. Similarly, we have our sub agents. So this is our proposal agent. You can go through the instruction. The tool which we are providing to our proposal agent is the store PDF. So this store PDF is going to basically upload the PDF into the cloud storage bucket using this tool. So you see, we have in the instructions we have given that After clarifying the user's intent, generate PDF file content for renovation proposal, and then upload the content as a PDF file in the cloud storage bucket using the store PDF. So we have this proposal agent. Similarly, in permits agent, we are giving more, uh, few more tools like send email, get contract from GCS, get permits compliance codes. So contract which is created by the permits can be used by this agent. So we have another tool which is going to fetch that from the Google Cloud Storage. So if you see the instruction over here, if the user has a proposal document created on their own, ask them to provide the file name for the proposal document file from their cloud storage bucket, right? And for ordering agent, we have again to get the same tool which we are using in the permits agent, get contract from GCS, get ordering data, and check status. Now, if we check these functions, you can see all the function definitions and implementations here. We'll quickly check the, yeah. So this is the check order status endpoint. This is the cloud run function endpoint where we connect to the Alloy DB and fetch the relevant orders. Okay. So you can go through this agent.py. Uh, if you have any questions, you can post it in the comments. Moving on. Yeah. So we've gone through the source code, the code of how agent.py is written. Then, from the setup point of view, you have to set up a cloud storage bucket. You can name your bucket anything, but like it depends on you. Whatever name you are giving, you just need to make sure that that name is provided in the ENVs. So in your ENVs, you provide the storage bucket name. So you need to create a cloud storage bucket. This is where your PDFs will be stored. Or if you want to provide any additional context to your agent, you upload it to your cloud storage bucket, and the agent will be able to refer it from there. Right. Uh, you can go through the documentation. It is pretty detailed, and it has a good explanation. Then we will, yeah, quickly go through the data flow and the key concepts. So the user initiates a request through the ADK interface, and the request is received via the root agent. Root agent analyzes the request and it routes it to the appropriate sub agent. The sub agent uses LLMs, knowledge bases, APIs, and databases to process the request and generate the response. And then the sub agent returns the response to the root agent. Root agent combines the responses and provides a final output to the user. Okay, we'll see this in the ADK web as well. Then this is your database setup. You will have to create a cluster for Alloy DB. You'll have to insert the document, the data into the table. You have everything available here. You also have the script available, the DB script available, which is going to create the table and insert the data into the table. So you can go through this, create your database, ingest your data, and then you create a cloud run function uh, which is going to connect to your database and execute the queries for you. Okay, moving on. Then you need the your API key from the Google AI Studio. I think in the last session we spoke about accessing the API key from Google AI Studio, but yeah, I can quickly show it now. Go to the aistudio.google.com, click on the get API key, and you should be able to yeah, get your API keys from here. Then add all the env variables, your API key, your cloud location, project, Google Cloud Project, project ID. I think this both are same. Then your cloud region, storage bucket. This check order status endpoint is your cloud function endpoint to read the data from the Alloy DB. And then you run your agent. So we will quickly go ahead and run the agent. I've already done all the setup. So I need to activate my virtual environment. So I'm going to activate my virtual environment, and then I'm going to oh no, actually I need to run the renovation agent, so I'm just going to do ADK web here. Okay, let's give it a few minutes for it to run, but once this runs, we'll be able to go to the ADK UI and test our agent. So the ADK web server has started. Okay, you can see your renovation agent is selected over here, and we will query this. So let me, yeah. So we're going to ask it to generate a proposal document for us. Go here, like generate a proposal document for the kitchen remodel requirement. And I'm not providing it any specifications. Whatever is given in the instructions, it is going to use that and generate the document for me. So now the agent is processing it. It's going to figure out which agent uh, to use for this particular query. We can see the console here. So wait, something is wrong. Okay, something is wrong. 1 second. Loaded env. Failed to convert project number to project ID. Okay, let's quickly check what's happening. Cloud Manager API has not been. Okay, this should work. Uh, 1 second. I think I know what the issue is. Okay, let me open the editor and show you how the code looks like. I think I was trying to deploy it. That's why it is stuck. So let me open the, yeah. So if I want to run the ADK web, I just need to comment this part out. Yeah. So there is a piece of code which I've not walked you through, but you can basically deploy this to your Vertex AI agent engine, and this is the code to deploy your agent to agent engine. But before deploying, we want to test it and see how it works. So let me comment this out and go back to my terminal. Yeah, I'm gonna stop this. Okay. I think it was port 8000. No? Okay. All right. Let me try running this again. Okay, it says that is already in use. I'm pretty sure it is this command. 1000. Or is it? It's not in bash. Oh. Okay, I'm gonna take help of Gemini. Let's see. How do I kill? No, this. Okay, the bid is 934. Okay. Kill -9. Okay. 943. I'm hoping. Okay, yeah, we can start it again. Yeah, let's give this another try. Okay, yeah, now it's working. So you can see all the reasoning over here because we have printed out everything, but let's go to the ADK. It is taking time to respond to the events, but yeah, if you see over here, okay, yeah, you see you have received the events as well here. So the first event was transfer to the agent. So it figured out that it needs to transfer the query to the proposal agent because we are asking it to generate a proposal document. Okay. Uh, it came here, it figured out it is using this transfer to agent inbuilt functionality. And it has transferred the control to transfer to sorry, to this proposal agent over here. Okay, you can check how much token it processed in each step. Then you can also check the request. So this is the model which it is using, this is the system instruction which it is using, and this is the input which has been passed, right? Now this is, at this step it has just figured out that proposal agent can help. Now I think this is where it is going to call the this is where your proposal agent is in control, and the proposal agent then figures out that it needs to use the store PDF tool. So you see over here in the tools, transfer to agent was done. Yeah, this is the description for your tool. Wait, I'm trying to check. There's a way where you can check the reasoning. You can check what input has been passed to this tool. In the request only, you should be able to see. Okay, yeah, this is the input which came in, and then it called this tool with this parameter, and it has responded with that it okay, this is this stage, it has responded that it needs to use the store PDF tool, and it needs to process it needs to generate the PDF content. And at this point, this store PDF tool has been executed, and you see it has successfully uploaded to GCS. So this is where it figures out that it needs to call the proposal agent. This is where the agent executes, then it figures out that it needs to call this tool, and it then executes that tool. And this is the final result after like this is the final response which the agent generates. Now if you go here, if we go to our storage bucket, we should be able to see, yeah, you see the proposal document for user, and I can actually download it, and this is the document which was generated by your agent. Now we'll quickly also check the DB connectivity thing, and we'll move on. um, so I think I can just ask it what is the status of my order. Okay. Meanwhile, it processes it. It takes a while to process it. We'll look at the deployment. So, if you want to deploy your agent to Agent Engine, you can just use the Agent Engine SDK. Okay. Uh, and you can create this ADK app, and then you'll have to create a remote app in Agent Engine. You do agent engine dot create, you provide this app, which is your ADK app, and you give the list of requirements which would be needed for this app to run. And this is going to deploy your code, your agent to Agent Engine. There are This is in your Python script, you can just write it. There are execution, like one line deployment options as well. So you can do ADK deploy Cloud Run. If you want to deploy your agent to Cloud Run, you can specify your project region, service name, app name, and everything, and you can deploy your agent to Cloud Run. You can also use this command to deploy your agent to Agent Engine. So you provide the deployment option. If you want to deploy on Cloud Run, you provide it as Cloud Run. If you want to provide deploy to Agent Engine, you provide this as Agent Engine. Provide your project ID, region, staging bucket. This is where your artifacts, bundled artifacts are stored, and uh, that is it. I think you just need to provide these parameters, and it is going to deploy your agent to Agent Engine. Uh, Going back, okay. Okay, this is messed up. Ideally, it should be able to call the cloud function, but let me just check if I'm giving the right query or not. I want to check the order status. I think it should have worked. Something is wrong. I don't know why this is not calling the cloud run function. It is again calling the proposal document, which should not happen. Ideally, it should go to the ordering agent. So here now you can see that your no, it is going to the ordering agent, but then ordering agent has come back and asked for the contract file name. Okay. And then okay, yeah, so this now has come from your ordering agent. And now when I sent, I want to check the order status, this has now gone back to your ordering agent, and it is calling this check status function. And in this check status function is where we were making that cloud run call to the cloud run function, which was connected to the alloy db, and it has now fetched the data. So you can actually check this as well in the alloy db. Hmm, right. If I go to the AlloyDB studio, will I be able to Postgres? What was the oh, oh password is AlloyDB. Okay, right. You can check the actually I can uh you can actually check the data here as well quickly. Yeah, so this is the data which we inserted, right? And this is what it has fetched. So if I go here, this is the data which it has fetched. So yeah, it is successfully connected to your DB and get got the order status with order ID and everything. Um, Now moving back to your agent engine, we'll quickly check the deployment to agent engine. Yet you see, so the agent is deployed over here, and you can check you can check these matrices for you can check the query per second, query latencies, and yeah, you can also check the container CPU allocation, memory allocation, all of this you can do. You can get your API URLs from here, the query URL, stream query URL, and you can use this in your app. There is a sample test script which you can use. Let me quickly walk you through that. Deployment to result. Yeah, so this is the test.py which you can use to test your agent, and it is actually very simple to test it. So once you deploy it, you get the reasoning engine ID. You can get the URL by just doing agent engines.get and the reasoning ID. And so this will return you your agent, and you can then just do agent.stream query, and this is gonna execute your agent for you. So give it a try, and if you have any more questions, let me know. But this is it for this session. Before ending it, if you're trying this code lab, make sure to clean up the resources, because we're using a database cluster, cloud run function, we're using agent engine. There are a lot of resources and they are expensive. So make sure once you are done, you shut down your project or you delete your resources, and that is it. Thank you. Let me know in the comments if you have any questions or if you're facing any issues in running the code lab.
Thank you, Nisha. I think it was useful and very interesting.
Thank you.
See you soon.
See you soon. Bye bye.